How was the Great Pyramid really built? The Great Pyramid of Giza in Egypt is one of the most famous buildings ever constructed. We know many things about it with surprising certainty. We know exactly when it was built. Construction began in 2547 BCE, more than 4,500 years ago. We know who ordered it to be built: the pharaoh Khufu. We even know who supervised the construction: the pharaoh's brother. And yet, despite all this knowledge, one mystery has puzzled scholars for centuries. How was the Great Pyramid actually built? The pyramid is made of around 2 million stone blocks. Each block weighs, on average, 2.5 tons. The real challenge was not cutting the stones. It was lifting them to great heights and fitting them precisely into place without modern technology. Over the centuries, many theories have been proposed. One of the oldest theories comes from the Greek historian Herodotus, who visited Egypt around 450 BCE, when the pyramid was already 2,000 years old. He suggested that the Egyptians used cranes, similar to those used in construction today. At first, this sounds reasonable. Herodotus may have seen wooden cranes used in Egypt, but there is a serious problem with this idea. Cranes need a wide and stable base to stand on. As the pyramid rises, the stone surface becomes narrower and narrower. Near the top, there is simply no place for a crane to stand safely. So that theory doesn't work. Another popular idea involves the use of a large ramp. Workers could drag stone blocks up the ramp as the pyramid grew taller. But here again, physics creates a problem. The ramp could not be too steep. To reach the top of a pyramid, more than 130 meters high, the ramp would need to be almost 2 kilometers long. The Great Pyramid stands on the Giza Plateau, a flat area that is simply not large enough to hold such a massive ramp. So scholars looked for another solution. If you have ever driven on a mountain road, you know that roads curve and bend to avoid steep slopes. This inspired another theory: a ramp that spiraled around the outside of the pyramid. But this idea also has a fatal flaw. One of the most remarkable features of the Great Pyramid is its extraordinary precision. The dimensions are almost perfect. To achieve this accuracy, engineers would have needed to measure the pyramid repeatedly during construction, especially from the 4 base corners. An external spiral ramp would have buried those corners, making accurate measurement impossible. So what if the ramp wasn't on the outside at all? This brings us to the most recent and compelling theory. An architect named Jean-Pierre Houdin spent years creating detailed computer models of the pyramid's construction. His conclusion was elegant and practical. According to Houdin, the builders first used a short, straight external ramp to construct the lower third of the pyramid, rising less than 50 meters. Once that part was complete, the rest of the pyramid was built using an internal ramp that spiraled upward inside the structure itself. This design would allow the base corners to remain visible, enabling precise measurements throughout construction. But how can such a theory be tested? One powerful technique is called microgravimetry. This method detects tiny variations in gravity to reveal empty spaces inside massive structures. In 1986, French scientists conducted a microgravimetric survey of the Great Pyramid. The results were remarkable. The data revealed a spiral-shaped empty space inside the pyramid, exactly where Houdin's internal ramp would have been. The shape and position matched his model almost perfectly. After centuries of speculation, we may finally be close to the answer. Even Herodotus, the ancient historian who first tried to explain the pyramid's construction, might have been convinced. The Great Pyramid may no longer be a mystery of guesses, but a masterpiece of engineering, understood at last.